Okay, so we have a question that says, at the instant shown, at this time, car A and the car B, they are traveling with the given speed of 55 mph and 40 mph. B is increasing its speed by 1200 miles per hour squared, while A maintains a constant speed. So this one is constant. But this one has an acceleration of 1200 miles per hour squared. And then my question will be to you, is it a tangential acceleration or is it a normal acceleration? You can pause and think about it. And this acceleration is the tangential acceleration because, as I said in our previous recordings, that this one increases speed. Okay, the normal acceleration is the one that keeps the body in the curved path. So the more normal acceleration, the more the body is in the curved path. And the normal acceleration, AN, as I told you, it's also called the centripetal acceleration. Okay. So determine the velocity of and the acceleration of B with respect to A, and then the radius of the curve is 0.5. That's the rho. Let's do that. It is not a difficult problem. It is very easy. So you need just to remember this formula here. The velocity of B is equal to the velocity of A plus the velocity of B with respect to A. That is your, the solution for the problem, the equation. And then we need to put the coordinate axis. So say that this will be my y coordinate axis. Let's add it, the y coordinate. And then I will put this one as my x coordinate axis. Okay, but you can go the other way around and then you can put the x axis this way. Okay, but it's up to you. Okay, however you feel, you can put your x axis. But this way the problem seems easier for me because if I put the x axis this way, then this one will be negative and this one will have negative component. So I don't want to deal with the negatives. I want my quantities to be positive and then, positive, optimistic. So let's solve it now. Let me just add it here. So this is the car B, and then we have the car A. Okay, and then the velocity of car A is given as 55 mph, and that one is 55. The car B, the velocity is 40 mph, yes, 40 mph. And this one has two components. One is in the this way, and one is in that way. Okay, and the angle is here as 30 degrees. And this one you can call it as the VB of x and then VB of y. And then the velocity of the particle B will be equal to VBx I and then VBy j. Okay, these are just unit normal vectors. The I and then j are unit normal vectors. Okay, so if you do that, then VB will be equal to, that was 30 degrees, then it will be that 40. The x component is cosine 30 I, and then the y component will be sine 30 j. Okay, and then for particle VA is just 55 I. Okay, then with this algebra we can solve it easily. So we will have the velocity of b, which is 40 cosine 30i plus 40 sine 30j, is equal to the velocity of a, 55i, plus the velocity of b with respect to a. And then if you solve it, let's solve the first part here. Cosine 30 is square root of 3 by 2, and then sine 30 is half. And if you use your calculator, then the square root of 3 is 1.7 divided by 2 is 0.86 times 40 and 34.6. So 34.6 I plus 20 j minus 55 I will be equal to VB with respect to A. So from here it follows that VBA is equal to, then I will just go with approximate values. This one will be 35, 55, negative 20i, and then plus 20j. Okay, and then if you draw in the vector sense, as you can see that I component is negative. So my direction for x was to the left. So therefore I component will be this one, because this one is 20i. And then I will have the j component, which is positive 20j, and then the velocity will be this one. Okay, this is the one that we are looking for. The question says that velocity and acceleration. The velocity we have determined, this is the velocity. You can even go further and then check the direction, I mean the angle here. What's that angle? This will be just the tan of these two velocity components. Okay, this is the part 1. Now the time is to look for part 2, which is the acceleration.